Hey, sixth graders, we're going to start taking some of our thinking about fractions and using it to graph points on number lines. So check out what this long example is saying, and then I will kind of translate it for you. So if b, as in the b right here, is a non-zero whole number, non-zero means not zero, then the unit fraction 1 over b is located on the number line by dividing the segment between 0 and 1 into b segments of equal length. So remember, here we're using b in place of a number. So in this case, b could be 4, it could be 6. So let's pretend for a sec that b is 4. And we're going to draw ourselves a number line. And since our definition here mentions between 0 and 1, that's what we'll put on our number line. So we'll have 0 here and 1 here. 1, 0. So the unit fraction, 1 over b, remember, from 5th grade, a unit fraction is any fraction with a 1 in the numerator. The unit fraction 1 over b is located on the number line by dividing the segment between 0 and 1 into b segments of equal length. So let's say just for this example, I'm going to say that b equals 4. So that means this unit fraction is 1/4. So then I am dividing the segment between 0 and 1 into b segments. In this case, b is 4. Check it out. Now I have 4 segments. 1, 2, 3, 4. And the value of each of these points would be 1/4, 2/4, 3/4, 4/4. One of the b segments has 0 as its left endpoint. Yep, this one right here, 0's at the left endpoint. The right endpoint of this segment corresponds to the fraction, unit fraction, 1 over b. Well, yes, the right endpoint, the endpoint on the right, which is right here, does correspond to 1 over b. 1 over 4. That's ugly. Let's try it again. So this is basically saying that in a unit fraction, the number in the denominator is how many pieces your whole has been divided up into. In this case, our whole is the space between 0 and 1, the value of 1. If the denominator is 4, it's been divided into 4 pieces. If the denominator is 7, it's been divided into 7 pieces. If the denominator is 292, it's been divided into 292 pieces, just like the fractions you know and love. Now we're just putting them on a number line. This section here, we're not talking about unit fractions. Now we're talking about any fraction. So we have the fraction AB. So that's A could be any number, B could be any number. So that's located on the number line by joining A, whatever number, of segments of the length 1 over B. So that 1, the left endpoint of the first, is at 0, and then the right endpoint. So that means you're stacking them up next to each other. So I'm going to draw another example. So here there's another number line showing the space between 0 and 1. And for this one, let's say that B equals, how about 3? And I'll say A equals 2. Because they didn't give me values, and this is algebra, so those numbers can be whatever I say they are. Mwahahaha, so powerful. So since B equals 3, that means I have to divide my segment into thirds. And then to show 2/3, since I decided that's what my mystery fraction is, then my first section I would graph right here, and my second section right here. And then I'm going to label 1/3, 2/3. Now, could I graph it so that I had 1/3 here and 1/3 here? No, that doesn't really make sense. They've got to go in order. And that's what this is explaining, is that you have to go in order from left to right. Since our number lines always go from least over here on the left to greatest over here on the right. All right, on your own, I want you to locate and graph the number 3/10 and its opposite on this number line here. Then you're going to complete the exercise below this. Once you've done both of those things, go ahead and raise your hand and I will come check in on you. And then you're going to be ready to watch the second part of this video. All right? All right. In this example, we're going to start using a new term. So it asks for a rational number. So earlier we learned about integers, how those are our counting numbers, 1, 2, 3, 4, our whole numbers. Now we're looking at rational numbers. And this problem has a rational number. The water level of a lake rose 1 and 25 hundredths feet after it rained. Answer the questions below using the diagram below. So this is a rational number. It's not an integer because it's got that 25 hundredths. It's not a counting number. But it's still a sensible number. We can understand 1 and 25 hundredths, so that's what we call a rational number. So write a rational number to represent this situation. 1 and 25 hundredths. Now what two integers is 1 and 25 hundredths between on a number line? Well, we know 1 and 25 hundredths is 1 and a little bit extra, so it's between 1 and 2. More than 1, less than 2. Write the length of each segment on the number line as a decimal and a fraction. Ooh, awesome. Let's check this out. I'm going to draw my number line. All right, there's my number line. And then 1 and 25 hundredths. Well, hold on. Let's write that as a fraction. And then I know I can reduce it. I can divide both of those by 25. 25 divided by 25 is 1. 100 divided by 25 is 4. So I have 1 and 1/4. Okay, so that means I've got to divide into 4 segments. So let's see. Here I am at 1, and then I go 1/4 to this point right here. So this is 1 and 1/4, or 1 and 25 hundredths. If I want to put it on my vertical number line over here, it's going to be right here. So that means I already did D. What will the water level be after it rained? I moved my water level up 1 and 25 hundredths. Here, maybe I can color it in. Whoop, 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 whoop. More water. After 2 weeks have passed, the water level of the lake is now the opposite of the water level when it rained. What was the water level when it rained? Oh yeah, we know this. 1 and 25 hundredths. What will be the new water level? Graph the point on the number line. Well, we know that the opposite of 1 and 25 hundredths would be negative 1 and 25 hundredths. So let's find that. Well, here's negative 1, and we have to go 1/4 from there. There we go. Negative 1 and 25 hundredths. For our last part of the example, state a rational number that's not an integer, whose value is less than 1 and 25 hundredths, and describe its location between two consecutive integers on a number line. This word we're seeing a lot of, consecutive, means right next to each other. 1 and 2 are consecutive because they're right next to each other. 2 and 3, 11 and 12. 24 and 25, those are all consecutive, but 1 and 8 are not consecutive. They're not right next to each other. So let's see. State a rational number, not an integer, whose value is less than 1 and 25 hundredths. How about 9/10? And its location between two consecutive integers? Well, 9/10, it is less than 1 and greater than 0. So that's a cheat way to describe what it's between. All right, now you're on your own making up your own story problem and onto the problem set. Good luck, team.